how hot do meteors get when they fall through the atmosphere? Very. Well, when they fall through the atmosphere, they're falling at probably something like 1 kilometer per second. Maybe it's a Mach 5 times the speed of sound. So I'd say probably could get upwards of 1,000 degrees centigrade. This is the reason why we see them, because they heat the air in front of them when they're moving through the atmosphere. So you have your meteor moving through the atmosphere, pushes on the air in front of it. The air pressure goes very high, the temperature goes very high, causes the meteor to catch fire almost. It glows, and that's what we see as a shooting star. I mean, they come from outer space, so they're going really fast, and then they hit the atmosphere and they slow down a little bit, but they're going so fast that they're still traveling at a very high speed. Is red dwarf politically correct? Oh, I don't know what that means. What exterior factors can affect the lifespan of a star? Okay. How long it's going to live? Okay, that would be the mass. Typically, big ones, the big ones shine really bright, but they die quickly. This is life, right? The small ones just give off a little bit of light and live forever, and are still around now. Since some have been around since probably the beginning of the universe. That's why the majority of stars in the universe or in the galaxy are little. They're all pretty much all what they call M dwarfs. They'll just shine forever, but just don't give off much light. If you give off a lot of light, you die. What else have we got? Let's have a look. There are quite a few here. Conditions change in a binary star system. Conditions for life. That's a good question. We don't really know that. You'd have nice sunsets, they used to think that binary star systems couldn't be stable for planets, because when you run computer simulations, if you have two stars and you throw in a planet, it tends to go in some weird orbit. But eventually, it settles down to an equilibrium orbit, and they've shown that these orbits can be stable. So it's possible that you could have a planet around a binary star system. I'm not sure if life would evolve or not, really. Difficult to say. Will we go over weird phenomena like constant speed of stars orbiting around the center of the galaxy? This guy knows something. He's talking about dark energy and dark matter. Oh yeah. Okay, so because of dark matter, things orbit in funny ways. You would expect the galaxy stars to orbit the galaxy in a certain pattern, and they actually go a lot faster because there's a lot of mass that we can't see, and that's called dark matter. It's like 78% of the mass or something like that. I don't remember. It's a lot anyway. Something like that one. How are we sure of the chemical compositions of asteroids still in space? Well, we're not really, if they're in space, but we have an idea where they come from. Most of them come from the asteroid belt between Mars and Jupiter. We assume that the ones that have hit the Earth, that have come from the asteroid belt, are made of similar stuff to the ones that are still in the asteroid belt. What makes the gaps between the sections of the main asteroid belt unstable? So these are the ones, if they're unstable, they have a chance of leaving the asteroid belt, and then they have a chance of hitting Earth. It's still unlikely, but what makes them unstable? Well, that's because of the tug of Jupiter on things in the asteroid belt, and sometimes if they're in the right place lined up with Jupiter, Jupiter can actually tug on a particular asteroid. Say once every year it tugs it a bit like pushing a child on a swing. If you push the kid on the swing, every time the kid's moving, the swing amplitude gets larger and larger. That's a bit like Jupiter. So Jupiter, every, say, whatever it is, X years, lines up with an asteroid, keeps pulling on it. Eventually it rips it out of the asteroid belt, and then it goes into some other elliptical orbit, and it could potentially hit the Earth. Those are called Kirkwood gaps. So that's the reason they're unstable, because they get pulled by Jupiter. And the others pull a little bit, but Jupiter's the big one. It's also Jupiter's, the other planets aren't close to the asteroid belt, because the asteroid belt is probably somewhere between Mars and Jupiter, right? Here's an interesting one. Given that the asteroid belt has a mass of equal to about 4% of the Earth's moon, is the asteroid belt in fact an obstacle for potential spaceflight missions? No. Why? Well, the asteroid belt is old. It's probably about 4 billion years old. Typically, it's like the age of the Earth or the age of the Sun, 4 or 5 billion years. And it's old, which means it's been around for a long time, and they've been hitting each other again and again. And at this point, the average distance between an asteroid is about probably 100 million miles. There was a clip in Star Wars where they show them hitting an asteroid belt, and they had to fight their way through it, and they say the probability of getting to an asteroid belt or surviving an asteroid belt is 1 in X trillion. Well, it's not actually, it's the other way around. It's probably the probability of getting not hitting anything is 1 in X trillion. So asteroid belts are pretty safe to go through. Voyager 1, Voyager 2 notice, went right through it, nothing ever happened. There's a question of scale, really. If you want to draw the solar system on a book, and you want to show the asteroids, you can't really show them that far apart, because you wouldn't be able to see them in the book. One of the students says here, this was with respect to somebody coming to talking about meteorites, I didn't understand what he meant by no return trips. Well, no return trips, basically that we haven't had any return trips to anything other than the moon. So this is why meteorites are the only example of something coming from another planet that, that we haven't actually been to another planet and brought anything back, whether it's a robot mission or a human mission. The moon, we brought a few bits of the moon back, but nothing else. So that's what he means by no return trips. Why are the stars in a galaxy aligned in a plane? Okay. Well, that's when it's created, when the solar system's created, things tend to feel something called the centrifugal force, let's say, which pulls them outwards, and eventually, because of the centrifugal force pulling them in a certain direction, the direction that the system's rotating, they tend to end up in a plane rather than at an angle to the plane. So galaxies and solar systems, etc., all tend to form in a plane. Well, it's a relatively simple one. Someone's interested in asteroid mining. That's a hot topic right now. Certain people are seriously thinking about mining asteroids. I mean, it's essentially it's trillions of dollars worth of minerals on an asteroid. So if you could mine one, there's a lot of money in it. They are landing. There's a mission to land on an asteroid. I think it's a European mission to land on an asteroid. I think it's this year or next year they're planning to. The first time something's actually landed on one, and do some experiments. The student here wants to know about the practical applications of landing and policy, and what scientists have been collaborating. The writing's gone a bit funny here. They'd like more in-depth discussions about the 3 elements that were produced in the Big Bang, which are, of course, hydrogen, helium, and lithium, and background radiation. And finally, what's the difference between a meteor and a meteorite? All right, the difference is a meteor is one that's going through the atmosphere and hasn't hit the ground yet, and when it hits the ground, it becomes a meteorite. a meteorite hits the ground. Thank you. Yeah.